This little diagram may go some way towards explaining exactly what happens whenever a pivot wears the hole that it's running in an oval. As you can see on figure A, if you've got a perfectly round hole and a perfectly round pivot, and the driving force of the movement pushes that pivot to one side of the hole, and you can see there that although this is exaggerated just for illustration purposes, you can actually see that there isn't a great deal of bearing surface in figure A. In figure B we see here one that is worn. The drive of the movement has pushed the pivot to one side of the hole. It has worn itself into that exact profile of the pivot, and of course it makes matters worse whenever it runs out of oil. It dries up and the friction becomes even more severe. As you can see from figure B, there's about 3 or 4 times as much bearing surface, and this together with the lack of oil and the gearing effect which takes place through the train of wheels in the movement just overcomes the force of the drive, the springs. It overcomes it and your clock will stop. And usually the last thing somebody does then is to wind the clock up, and then they bring it to me and say, this clock's overwound. I'm sure you've heard of that term before. Okay, thank you for watching.